The university offers a PCB manufacturing service, where you can submit Gerber files alone for simple PCB fabrication, or Gerber files accompanied by a bill of materials and a component placement file for surface mount assembly. PCBs are manufactured through JLCPCB, and they have certain requirements for the files that are submitted to them for manufacture, which is what I will outline in this demonstration. JLC will only assemble one side, so keep all the surface mount components that you wish to have assembled on the one side of the board, preferably the top side for simplicity. As you see, I have an example design here, which I will use to demonstrate the file preparation and submission process. For an unpopulated PCB, a zip file containing the Gerber files must be provided. Gerber files are simply text files which contain the PCB information. The zip file contains a number of these text files. Each one contains the data for the individual layer of the PCB, such as the copper, silkscreen, solder masking, and drill holes. And most PCB CAD software will give you the option to select which layers you want to export. I would suggest you export all layers, as the manufacturer will simply ignore the irrelevant ones. For an assembled PCB, two further files are required: a bill of materials, or BOM file, and a component placement library, or CPL file. Both are simple CSV format files. The CPL file should be generated by the PCB CAD software. Some PCB CAD software also includes the ability to generate and export BOM files as well, but if not, these can be generated directly using Excel, which I will also show. Let's look at the CPL file first. This is a file which contains information of all the component positions, including the X and Y coordinates, rotation, and layer. It's a CSV file, so I can open it in Excel. We see here the values as exported from my CAD software. I need to format the entries to make them compatible with JLCPCB. First, the headers need to be specifically named as follows. The component designator needs to be headed as designator. The X and Y coordinate columns need to be headed as mid-X and mid-Y, as shown. The package column is unnecessary, so I can remove that column. Layer is headed as layer, and the field should contain either top for top layer or bot for bottom layer. Rotation is headed as rotation, and the values are in degrees. The coordinates must be in millimeters with the units shown. My coordinates do not have their units appended by default, so I will have to add them manually. In a separate column, type equals to generate an equation, then select the cell containing the X coordinate value, and then add ampersand, open quote, close quote. Then enter. This has now brought the value forward with the units appended. Do the same for the Y coordinate value, and then drag down to autofill the rest. Select and copy the new values, and then right-click the original cell and click Paste Values, shown as the little clipboard with a 1, 2, 3 overlaid. This is important, otherwise it will paste null values. This CPL file is now correctly formatted for JLC. Your file must be laid out exactly like this, with the headers labelled as shown. Now for the bill of materials file. As I stated earlier, your PCB CAD software may have a BOM feature, but if not, you will need to generate it manually in Excel. Regardless of how you generate the BOM file, it must adhere to the following format to be compatible with JLC-PCB. Proteus does have a BOM feature, but for demonstration purposes I'll create mine manually. First we need 4 columns, headed References, Value, Stock Code, and Comment, in the order shown here. And I will save this in my directory as bom.csv. The reference column contains the component designator from the design. For discrete components such as resistors, capacitors, and inductors, the value column just contains its resistance, capacitance, or inductance value. For other components, it can just be the part name, but it's not majorly important. JLC-PCB have a library of components they stock for surface mount assembly. Any components you wish to have assembled by JLC must come from this library. On the JLC-PCB website, go to Resources, Surface Mount Parts Library. Here you can browse through the subcategories or enter the part parameters into the search tool. For example, my design contains a capacitor with a value of 100 nanofarads and a package size of 0402, which is an SMT chip resistor. I type 100 nanofarads and 0402 into the search and hit enter, and a number of results come up. These can be subdivided into basic and extended parts. Basic parts are preloaded onto the pick-and-place machines, whereas extended parts have to be loaded manually, so JLC will charge extra for extended parts used. Therefore, you should always try and find a basic part first, and only resort to using extended parts if absolutely necessary. Basic parts also tend to be much better stocked than extended parts. Discrete components like resistors and capacitors are plentifully available in the basic parts range, so I filter by basic parts and make my selection. I have a match, and I click to open the details, and I see that it's a 16V 100 nanofarad 0402 package, which will do nicely. I need to copy two numbers from the page into my BOM file. First, the LCSC part number, which usually begins with a C and is followed by a number. I click copy and paste it into the stock code column. I then also copy the manufacturer's part number and paste it into the comment column. Now I fill in the other columns. The capacitor ID in the design was C18, so that goes in the reference column, and the value was 100 nanofarads, so it goes in the value column. There are also other 100 nanofarad capacitors in the design, C11 and C15 for example, and are the same type, so I can enter these designators into the same line, separating them with a comma. Now all of these capacitors will have the same part assigned to them. Repeat this process for all components, and you should finish with a spreadsheet that looks like this. It's important that both the stock code and the manufacturer part numbers are copied into the columns as shown here. It's also very important that all grouped component references are separated with commas, as shown here. This will all become apparent later. If you don't already have a JLCPCB account, it's advisable to create one, as it will allow you to perform test uploads to make sure everything is correct before you submit. It will also allow you to purchase PCBs yourself without going through the university system if you wish. On the JLCPCB front page, click Quote Now. Select Add Gerber File and browse to your zip file containing the Gerbers. The board dimensions should be filled in automatically, but if not, then enter them yourself. Select the attributes for the PCB, such as quantity and color. The other settings should be acceptable for most applications left as they are. If you are ordering an unassembled PCB, then you can submit the design to the cart here. For assembled PCBs, click SMT Assembly. Select the layer to be assembled, accept the terms and conditions, and then click Next. Upload the correctly formatted bill of materials and CPL files, and then click Next. This next screen shows which parts from the library have been assigned to each component in the design. Most of them should be correctly selected by default. This is why we filled the bill of materials file with both the stock codes and the manufacturer's part numbers before. Have a quick inspect just to be sure none have been misselected. Or in some cases there may be a complaint because stock of a certain component is insufficient, in which case you can click the search glass to look to see if there's a suitable drop-in replacement. For example, here there's a 470 microfarad tantalum capacitor I had selected, but it's out of stock. So I click the search glass and look to see what's available. I can then either just select one of the suggested replacements, or if they're not appropriate, I can search for a suitable replacement here. If the available alternatives are too restricted, you may need to adjust some parameters to suit. For example, this capacitor is just used for decoupling a power line, and the required value is fairly flexible. I can try reducing the value to say 330 microfarads, but using the same 7343 package, and see what's available. There are plenty more options here, and stock numbers are better, so I will use one of these. Once all is satisfactory, click Next, and a preview of the completed board should be generated for you. This can be the most tedious step, because various PCB CAD packages have different orientations for their components, so you may find components 90 degrees or 180 degrees out of position. You see there are some here. Resistors don't matter, but polarized components like diodes, electrolytic and tantalum capacitors and IC chips will not work if placed the wrong way round. If a component is misplaced by 90 degrees, that's usually easy to spot. But take extra care to make sure polarized components haven't been misplaced by 180 degrees. This is easy to miss. Diodes have a plus for the anode and a minus for the cathode. Similarly, polarized capacitors have a plus for the positive terminal. IC chips have a spot denoting pin 1. These must all match the positions shown in the design, so there may be a lot of toing and froing between the design and the preview to ensure all components are positioned correctly. To correct an incorrectly rotated component, the corresponding angle will need to be adjusted in the CPL file. Let's correct some of the errors in my design. C12 is 180 degrees out of position. In the design, the positive terminal is on the right. On the preview, it's on the left. So I find C12 in the CPL file and adjust the rotation value by 180 degrees. I can decrease the angle from 180 to 0 to rotate the component clockwise, or I can increase it from 180 to 360 to rotate the component anti-clockwise. It makes no difference as long as it finishes in the correct position. U3 is also 90 degrees out of position. In the design, the spot indicating pin 1 should be at the top left. So I need to rotate the chip 90 degrees clockwise to correct this. I find U3 in the CPL file and decrease the angle by 90 degrees. U4 and U2 both need to be rotated clockwise by 90 degrees. To position pin 1 the same as in the design. So I find them in the CPL file and decrease the angle by 90 degrees. U5 is not so easy to see, because it doesn't show as being misaligned on the pads, even though it is actually in the wrong position. You can see that the spot is in the bottom left, whereas it should be in the top left. So it needs to be rotated 90 degrees clockwise. Now here are some less obvious ones. These 3 LEDs are incorrect. Remember, the plus represents the anode and the minus is the cathode. In the design, the LEDs have their anodes on the left and the cathodes on the right. In the preview, they're the wrong way round, so must be rotated 180 degrees. The same applies to C16. These could all be easily missed by a quick glance, so care must be taken at this stage. After correcting all the errors, go back to the file upload stage and re-upload the modified CPL file. You will need to repeat any component selections you made here, but now when the preview is generated, the component should be positioned correctly, if you have made the right modifications. See now that the IC chips line up with their pads, and the polarized components are the right way round. As I said, this can be tedious, especially if you have many components, as you may need to repeat this check and adjust cycle multiple times. But when finally all is satisfactory, you can either submit your order to the cart if you are buying yourself, or submit the finalized Gerber, BOM and CPL files to the faculty for processing.